Good morning, everyone. Hopefully you're all super excited to learn even more about quadratics in vertex form. Sorry, was that a little too excitable? Some of you said you wanted me to be enthusiastic when I was teaching, so that was me trying to be a little enthusiastic about quadratics. But let's just get to it. Last week, in the last set of notes, we were able to look at an equation in vertex form, and we were able to say, hey, that's the vertex. And then we looked at the graph, and then we were able to find the equation by looking at the vertex and then any other point on the graph. But it's not all about the vertex. We still have to find other things. We still have to find the Y-intercept. We still have to find the X-intercept or X-intercepts. So this lesson will focus on all of those other things that we can find from vertex form. So we're going to start by finding the Y-intercept, and I think that's going to be a relatively easy concept for us. So what I have on there is 4 different graphs, and there's a dot on the Y-axis. Those are going to be the Y-intercepts. So for that first blue graph, the Y-intercept is going to be located at 0, 10. If you look at the red graph, it's right there, and that's located at 0, 3. We're going to go down to the green graph, and that green graph has a dot right there, and that looks like it is at 0, -4. And if I go to that purple graph down on the bottom, that Y-intercept is at 0, it's an ugly 0, -8. So if you look at all of those Y-intercepts, what do they have in common? Well, hopefully, as you're looking at these, you look down here and you see 0, 0, 0, 0. They all have a 0 for the X coordinate. I'm going to abbreviate coordinate. So anytime you ever want to calculate a Y-intercept, it's very, very, very simple. All you have to do is replace X with 0. Because every single Y-intercept on this planet has an X coordinate that is equal to 0. So now knowing that, let's go ahead and find a couple Y-intercepts of the following quadratic equations. So we've got this quadratic equation. We can look at it and we know that the vertex is at -2 and 17. That's not what we're looking for today though. We're looking for the Y-intercept. Some of you might kind of confuse that notation and think, oh, it's the Y coordinate of the vertex. No, 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 no. So the Y-intercept is where X equals 0. So all we have to do is take this and replace X with 0. So now that we've replaced X with 0, we can just simplify and evaluate. So 0 plus 2 is just going to make it 2. 2 squared is 4. So we have -3. 2 squared becomes 4 plus 17. If you take -3 times 4, you get a -12 plus 17. And your Y-intercept is going to be 5. Now I kind of prefer you write your Y-intercept as a coordinate. So I would write it as 0, 5. And there's your Y-intercept. That's not so bad, is it? We'll try one more just with a decimal. Again, if you look at this one, you can look at it and you can immediately say, hey, I know the vertex is 3, -10. But on this question, I didn't ask you to find the vertex. I asked you to find the Y-intercept. So we're just going to take that function and we're going to replace X with 0. Then we can simplify it. 0 minus 3 is going to be a -3. -3 squared means -3 times -3, which is a +9. So we have 0.5 times a +9 minus 10. If you take half of 9, that's going to be 4.5. And 4.5 minus 10 is -5.5. So it's going to be 0, 5.5 as your y-intercept. So go ahead and pause this video now. In a couple seconds, I'll go ahead and give you the answers to the next two. All right, hopefully you are back. And the answer to the first one should have been 0 and 2.5, 22.5, hopefully. I think, hopefully. For the next one, if you put in a 0 there, that's going to be a 36 times 5. That's negative 180 plus 400, 220. So it should be 0, 220. Hopefully I'm right about those. If I'm not, please, please, please let me know. Now we're going to move on to the X-Intercepts. So X-Intercepts, the concept is basically the exact same thing. Let's go ahead and look at the blue graph first. If you look at that blue graph, if we write the coordinates of the point right down here, that coordinate would be negative 10, 0. If we look at the red graph, it looks like we have one right there at 0, 0. The green graph is lucky enough to have two X-intercepts, and that first one is at negative 6, 0, and the other one's over there at 10, 0. And the purple graph has one right there at 4, 0. So hopefully you're looking at this and you kind of notice something once again. What do all of the X-intercepts have in common? Well, if you look here, 0, 0, 0, 0, 0. Every single X-intercept, no matter what the y-coordinate is 0. So once again, to find an X-intercept, all you have to do is replace y with 0. And that's going to work for every unit that we go to. Anytime you ever want to find an X-intercept, all you have to do is change the y to a 0. If you want to find a y-intercept, just change the x to a 0. And let's go ahead and do a couple examples here. So I'm asking you to find the x-intercept of this quadratic function. So in order to find an x-intercept, we have to replace y. This f of x is essentially the same thing as y. We have to replace y with 0. So I'm going to do that. So 0 equals 1/16 times x minus 2 squared minus 4. And now what we have to do is we have to solve for x. So to get x by itself, there's a bunch of things that we have to get rid of. And I'm going to get rid of the furthest thing away from the x first. So we start by adding 4 to both sides. So we get 4 equals 1/16 times x minus 2 squared. So I got rid of that minus 4. The next thing that I have to get rid of is that 1/16. So what I'm going to do here is I'm going to multiply it by 16 on one side, multiply it by 16 on the other side, and then those will end up canceling because 1/16 times 16 just becomes a 1. On the left side, 16 times 4, that's going to give us 64 equals x minus 2 squared. And here's where the tricky part comes along. Now we have to get rid of that squared symbol. And I think most of us probably are pretty comfortable with, to get rid of a squared symbol, we have to take the square root. So go ahead and take the square root. Take the square root. The square root of 64 we know is going to be 8. So we get 8 equals x minus 2. Because by taking the square root, what that does is it eliminates that squared symbol. However, when you're solving equations, it could also equal negative 8. Because if I did negative 8 times negative 8, it would also equal 64. So I have to set up a second equation here. Negative 8 equals x minus 2. So when you're solving equations and you get to a point where you end up taking the square root of both sides, you have to have one positive and then one negative, and then we'll just solve those separately. Over here, we add 2 to both sides and we get x equals 10. And over here, we add 2 to both sides and we get x equals negative 6. So our two x-intercepts would be at negative 6 and 10. And you could write those as coordinates. It would be 10, 0, and negative 6, 0. Not so bad, hopefully. And let's go ahead and do one more together. We want to find the x-intercepts of this one. So again, to find an x-intercept, all we're going to do is we're going to change this y to a 0. Then to get rid of that plus 10, we are going to have to subtract 10 from both sides. So we do minus 10, minus 10. To get rid of that minus 1/2, what we do there is we have to multiply it by negative 2. So those end up canceling out with each other, and negative 2 times negative 10 now becomes a positive 20. And we get 20 equals x plus 6 squared. Now we get to that tricky part where we have to end up taking a square root. So what we're going to do is we're going to take the square root here, we're going to take the square root here, and that squared will then go away. So on one side, we're going to have the square root of 20 is equal to x plus 6. However, remember there is a negative component to that, so we're also going to set up negative square root of 20 equals x plus 6. So now if you're solving for x, you can subtract 6 from both sides, and your final answer is going to be the square root of 20 minus 6. And you could turn that into a decimal, but a lot of times, especially on these IB tests, one of these tests is a no calculator test. And so they will specify that they want you to leave it as an exact answer. And this is an exact answer. It's one that doesn't involve rounded decimals. So a lot of times you'll just see square root symbols in there, or pi symbols, or the letter E, or fractions that aren't turned into decimals. So if they specify they want an exact answer, leave it as an exact answer like this. For the other side, similarly, just subtract 6 from both sides, and we get an x-intercept of negative root 20 minus 6. And if you wanted to, you definitely could turn those into decimals, and then you could just graph it on Desmos, and you could double check and make sure that you got those correct. But typically, we like exact answers. So there's times when decimals will be fine, there's times when exact answers are going to be needed. So go ahead and try the next 2 on your own. Pause the video here for a couple seconds, and then I will go ahead and give you the answers to those. Okay, welcome back. Hopefully if you did these correctly, for the first one you should have gotten x-intercepts of negative 2 and negative 6. And for the next one, you should have gotten one of those square roots again. You should have gotten the square root of 45 plus 8, and you should have gotten the negative square root of 45 plus 8. And I think if you turn those into decimals, you should have gotten 1.29 and 14.7 as your two x-intercepts.